Hi, my name is Ms. Fung, and today, in the last video of the polynomial series, we're going to be looking at application types questions. Example 1. Using the CAS, determine a cubic function which is approximately modeled by the following table of values. So here we have a lot of values. So you would go to your CAS and then go to the main menu, and for this example we would use not graph and table, we use statistics. So that button over there. And once you click on that, you'll have a table like so. And I'm just going to show you quickly what it looks like once you type in all those values. So your X and your Y values. And then to find the cubic, you would go to calculate regression, cubic regression, and it will give you this window. Click on, make sure you copy formula from Y1. And when you do so, you would get that in your calculator, where because we're doing cubic, A is the value in front of X cubed, B is in front of X squared, and C in front of X, and D is the value by itself. So you would copy these four values out and write your equation like so. Example 2. The course of a river as marked on a map follows a curve defined by the function. It looks like that. Find the coordinates of the southernmost point on the river between X is 0 and X is 2. So let's get a CAS calculator out. So for this question, we're going to use the calculator graph tape. So that button there. Then we go in here, we type in the equation. I've just typed it, but you can type it. And at the end of the equation, I'll show you how to restrict the domain. You go to keyboard, click math, and that line over there. And then we can now say what the domain is, which is 0 to X to 2. Hit enter, hit graph, and we would get something like that. Now it's asking for the southern, so the minimum. So analysis, G-solve, minimum, and then your values are there. So let me just quickly recap that. So type it in with the vertical bar. I couldn't screenshot that bit, but remember the vertical bar, and then you'll get that. And then when you click on the G-solve F minimum, the function's minimum, you will get that coordinate. What's the question asking for? Find the coordinate. So you will have your X and Y value there as well. Example 3. The map of a local council has two key features, the cubic river and the linear highway. I follow the following equations where X is the distance in kilometers. So 3A, sketch the river and highway showing X and Y axis intercepts. So we could sketch it using, again, the graph function. So just plug it in and sketch it. Example 3B, find the coordinates of the points of intersection of the highway and the river. To find the intersection, what would you click on? You would click on, again, analysis, G-solve, and then find intersection. So when in doubt, just click on analysis, G-solve, and try to find the word you're looking for. So if you do so, you would get a screenshot that looks like that. So those are the 3 points of intersection. Next example question, a fun run organizer wishes to arrange banners at the closest points of intersection. Find the distance between the proposed checkpoints. So the closest distance. So I could type in the distance between those two by typing in square root of the 2 points, and I would get 10.2 kilometers. I think I was a little bit quick. If you whip out the calculator, pause the video here and give it a go yourself. Example 4. A piece of wire 2000 centimeters long is used to make the edges of a cuboid with dimension as shown. So every line you see is part of the wire and adds up to 2000. Find W in terms of X. So we know that 2x plus 2x, how many 2x's are there? There's 4. And then 3x, how many 3x's are there? 4. And then W, how many W's are there? Can you see? And then 1 invisible behind there, 4. So we can write the formula 2000, the length of the wire, is equal to 4 of 2x's plus 3x's plus W. And then we can expand and simplify. So 2x plus 3x is 5x. and 2000 divided by 4 is 500. Now we want W in terms of X, so let's move the 5X over the other side, so it becomes minus 5X plus 500. For B, find the volume of the cuboid in terms of X. So the volume would be 2X times 3X times W, and we know what W is. So we substitute the W in, minus 5X plus 500. So now 2 times 3 is 6X squared minus 5X plus 500. State the possible values of X. Now we can look at this and solve for X, but we also know that it has to be greater than 0, otherwise you'll have no length. So solving for that, bring the 500 over as negative 500. Dividing by negative 5 means 100, and you change your sign. So X has to be less than 100. So X is between 0 and 100. Double check, if X was 100 minus 5 times 100 is 500, it will give me 0 for that bracket. And if X is anything more than 100, that negative is going to be very big, and it's going to make this negative, which doesn't make sense for a volume. So we can put that in GSolve and look for the root for with our CAS as well. We can do that. And that would give us the x-intercepts. For D, find the volume if X is 50. So all you have to do is bring up the formula from before and put X is 50. So you've done this a lot with quadratics and whatnot. And you would get 3,750,000 centimeters cubed. For E, what is the actual biggest volume you can have? Use the CAS, and then you go action, calculation, F max, and then F max, and that would give you something like that. But notice that you have to define your equation first, otherwise it doesn't know what it's looking for. So once you define your equation, you can go action and then calculation, F min max, and click on maximum for maximum volume, and then that you can change the settings to decimals, and it will give you a decimal, or exact, and it will give you exact. So for decimals, it will be 4,444,444 centimeters cubed. Thanks for watching, and to revise, you can click on any of the videos and try the questions again, especially the ones that you're uncomfortable with. And don't forget to subscribe, and I'll see you next time. Bye!